Hello, and welcome to episode 12 of Maths in an Empty Classroom with me, Mr. Southern. Today we're looking at example 3 from further kinematics in vector form. So here's the scenario this time. We have a particle P of mass 0.5 kilograms. This is the first time we've seen one with mass in it. It's moving under the action of a single force F newtons. So we have variable acceleration. The mass is going to be constant, which implies a variable force is being applied to that mass to make the acceleration change. So the force is not always the same force. At time t seconds, the position vector of p, r meters, is given by r equals 3t squared over 2 minus t cubed over 3i plus 2t squared minus 8tj. So I've tended to be using x for position. Here we have r, so throughout this example, to be consistent with what's here, I'm going to be using r for position. And we're being asked in part A to find the value of t when p is moving parallel to the vector I. So I've pre-prepared on the next page. I've just copied over the initial equation for position and what we've been asked to do. It's when it's moving parallel to I. Now I is the x direction, so if we're moving parallel to I, then the j component isn't changing. So the j component is 0. Now, how we determine direction is we use velocity, because velocity is the rate of change of position. So if the rate of change of position is not changing for j, it means that the velocity component of j must be 0. So, how do I get velocity from position? Well, by now we should be happy that you differentiate. So I'm just going to launch straight into it, that the velocity vector differentiating this would be 3t minus t squared I plus 4t minus 8j meters per second. So we said that it would be moving parallel to I beg your pardon, when the j component of velocity is 0. So what we're going to do is we're going to say the j component is 0. There's my j component. 4t minus 8 equals 0. Which means that t is 2. And I'm happy with that because going back and reading the question, it asked me for the value of t, so just thinking about strategy, value, there's only one, when p is moving parallel to the vector I, and I've got one satisfactory solution. Happy days. In part B, I'm now asked for the two values of t when p is moving parallel to the vector 5i minus 6j. Now, this is important. The vector that it's moving with isn't 5i minus 6j, it's parallel, which means it's a multiple of that vector. So in part B, I'm still going to be using the velocity vector because I'm still interested in its direction of travel. And what I'm going to do, and you'll be familiar with doing this with vectors as forces, with the stuff that you would have done in your first year A level, is I'm going to say the I component, 3t minus t squared, is going to equal a multiple of 5, because it's parallel to 5i minus 6j. I'll just jot that on here so that we know what's going on. Parallel to 5i minus 6j. Similarly, the j component, 4t minus 8, is going to be a multiple of negative 6. So it's negative 6 lambda there. You may be more familiar with seeing this initially written in column form, so I'll just do that over here, writing the velocity as a column vector, I component, j component equals a multiple of 5 negative 6, which is 5i minus 6j. But but we would go from that to there anyway, and we would look to solve simultaneously from there. Now, this is kind of leading me to thinking these look a little bit like the GCSE elimination style ones, and I don't see any reason to deviate from that at the moment. So I'm going to multiply the first one by 6, which gives me 18t minus 6t squared equals 30 lambda. And I'm going to multiply the second one by 5, which gives me 20t minus 40 equals negative 30 lambda. And the reason that I've done that is the next stage of my working, if I add the two equations, I will eliminate lambda. I don't actually care what lambda is, I'm trying to find t, so it's sensible. Just be careful with your signs. If you add those two together, you're going to get 38t minus 6t squared plus no other t squared part, so it's just negative 6t squared, adding negative 40, so negative 40 equals 0. What you can do at this stage is divide through by 2, change all the signs to get 3t squared minus 19t plus 20 equals 0. Now, checking as you go. I'm looking at that quadratic and I can see that I'm going to get 2 positive solutions for t, which is what I want. The way I know that is I've got a negative here and I've got a positive here. You should be expecting 2 positive solutions for t here because you've been asked for the 2 values of t when we're moving parallel to this vector, and we start at time 0. So rather than going back and checking through your work, build in strategies to check as you go, and that is one of them. I'm going to get 2 positive solutions from this. I'm using the calculator to solve the quadratic, putting in a as 3, b as negative 19 and c as 20. It's telling me that my first solution is that t equals 5, and my second solution is that t equals 4 over 3. So those are the 2 values of t when the particle is moving parallel to 5i minus 6j. What that means is, if I substituted t equals 5 back into my equation for velocity, this here would be a multiple of 5, and this bit would be a multiple of negative 6. Right, let's look at what we're asked to do in part C. The magnitude of the force when t equals 3.5. Okay, magnitude of the force, right. What do we know about the relationship between force, mass and motion? Well, it's that resultant force equals mass times acceleration. That's what we're going to be using. We're going to be using resultant force equals mass times acceleration. But we need an expression for acceleration. We don't currently have that. We have that velocity is 3t minus t squared I plus 4t minus 8j. Just check that. Good. And you know by now, acceleration is the rate of change of velocity. So we can differentiate v to get a. That's going to give me 3 minus 2t I plus 4j. So we're asked for the magnitude of f when t equals 3.5. So let's sub in t equals 3.5. Subbing in 3.5 there, we're going to get negative 4i. Subbing in 3.5 there, there's no t to sub into, so we're just going to get 4j. Now that's not the force, that's the acceleration. So if we now go to resultant force equals mass times acceleration, my mass was given in the question as 0.5. So if I multiply that by negative 4i plus 4j, I'm going to get my resultant force to be negative 2i plus 2j newtons. And as you can see, the acceleration depended on the time, which means so does the force. The force is variable because the mass is a constant. It's the variable force that's causing the variable acceleration. Now the question asks me for the magnitude of the force, so I'm not done. I've got to crack out Pythagoras to work out the magnitude of the force, squaring -2, squaring 2, and it would be fine to leave this in surd form, that the magnitude of the force when t equals 3.5 seconds is 2√2 newtons. Good job.